welcome back to this Comptia Network Plus series. Other important cable issues you need to know about. They may be basic, but they're still vital. An understanding of the physical issues that can happen on a network when a user is connected via cable, usually Ethernet, is critical information to have in your troubleshooting repertoire. Because many of today's networks still consist of large amounts of copper cable, they suffer from the same physical issues that have plagued networks since the very beginning. Plagued networking since the very beginning. Newer technologies and protocols have helped to a degree, but they haven't made these issues a thing of the past yet. Some physical issues that still affect networks are listed and defined next. Incorrect pinout, TX, RX, reverse damaged cable. The first things to check when working on cabling are the cable connectors to make sure they haven't gone bad. After that, look to make sure the wiring is correct on both ends to physically checking cable pinouts. Other important to remember is that if you have two switches, you need a crossover cable where you cross pins 1 and 2 with 3 and 6. On the other hand, if you have a PC going to a switch, you need a straight through cable where pins 1 and 2 correspondingly connect with pins 1 and 2 on each end, the same with 3 and 6. Finally, make sure the termination pins on both ends are the correct type for the kind of cable you're using. Bad port. In some cases, the issue is not the cable but the port into which the cable is connected. On many devices, ports have LEDs that can alert you to a bad port. For example, a Cisco router or switch will have an LED for each port, and the color of the LED will indicate its current state. In most cases, a lack of any light whatsoever indicates an issue with the port. Loopback plugs can be used to test the functionality of a port. These devices send a signal out and then back in the port to test it. Transceiver mismatch. Interfaces that send and receive are called transceivers. When an NIC is connected to a port, the two transceivers must have certain settings the same or issues will occur. These settings are the duplex and the speed setting. If the speed settings do not match, there will be no communication. If the duplex settings are incorrect, there may be functionality but the performance will be poor. Crosstalk. Again, looking back to chapter 3, remember that crosstalk is what happens when there's signal bleed between two adjacent wires that are carrying a current. Network designers minimize crosstalk inside network cables by twisting the wire pairs together, putting them at a 90-degree angle to each other. The tighter the wires are twisted, the less crosstalk you have, and newer cables like Cat6 cable really make a difference. But like I said, not completely. Crosstalk still exists and affects communication, especially in high-speed networks. This is often caused by using the wrong category of cable or by mismatching the member of one pair with a member of another when terminating a cable. Near end, far end crosstalk. Near end crosstalk is a specific type of crosstalk measurement that has to do with the AMI bled from a wire to adjoining wires where the current originates. This particular point has the strongest potential to create crosstalk issues because the crosstalk signal itself degrades as it moves down the wire. If you have a problem with it, it's probably going to show up in the first part of the wire where it's connected to a switch or a NIC. Far end crosstalk is the interference between two pairs of a cable measured at the far end of the cable with respect to the interfering transmitter. This condition is often caused by improperly terminating a cable. For example, it's important to maintain a twist right up to the punch down or crimp connector. In the case of crimp connectors, it's critical to select the correct grade of connector, even though one grade may look identical to another. Attenuation, dB loss, distance limitation. As a signal moves through any medium, the medium itself will degrade the signal, a phenomenon known as attenuation that's common in all kinds of networks. True signals traversing fiber optic cable don't attenuate as fast as those on copper cable, but they still do eventually. You know that all copper twisted pair cables have a maximum segment distance of 100 meters before they'll need to be amplified or repeated by a hub or switch. But single mode fiber optic cables can sometimes carry signals for miles before they begin to attenuate, degrade. If you go too far, use fiber, not copper. Although there is attenuation, dB loss in fiber, it can go much further distances than copper cabling can before being affected by attenuation. Latency. Latency is the delay typically incurred in the processing of network data. A low latency network connection is one that generally experiences short delay times, while a high latency connection generally suffers from long delays. Many security solutions may negatively affect latency. For example, routers take a certain amount of time to process and forward any communication. Configuring additional rules on a router generally increases latency, thereby resulting in longer delays. An organization may decide not to deploy certain security solutions because of the negative effects they will have on network latency. Auditing is a great example of a security solution that affects latency and performance. When auditing is configured, it records certain actions as they occur. The recording of these actions may affect the latency and performance. Jitter. Jitter occurs when the data flow in a connection is not consistent. That is, it increases and decreases is in no discernible pattern. Jitter results from network congestion, timing drift, and route changes. Jitter is especially problematic in real-time communications like IP telephony and video conferencing. Collisions. A network collision happens when two devices try to communicate on the same physical segment at the same time. Collisions like this were a big problem in the early Ethernet networks, and a tool known as Carrier Sense Multiple Access with Collision Detection CSMA-CD was used to detect and respond to them with Ethernet 2. Nowadays we use switches in place of hubs because they can separate the network into multiple collision domains. Learn the media access control MAC address of the devices attached to them, create a type of permanent virtual circuit between all network devices and prevent collisions. Shorts. Basically, a short circuit or short happens when the current flows through a different path within a circuit that it's supposed to. In networks, they are usually caused by some type of physical fault in the cable. You can find shorts with circuit testing equipment, but because sooner is better when it comes to getting a network back up running, replacing the ailing cable until it can be fixed, if it can be, is your best option. Open impedance mismatch echo. Open impedance on cable testing equipment tells you that the cable or wires connect into another cable and there is an impedance mismatch. When that happens, some of the signal will bounce back in the direction it came from, degrading the strength of the signal, which ultimately causes the link to fail. Interference, cable placement, EMI, and radio frequency interference (RFI) occur when signals interfere with the normal operation of electronic circuits. Computers happen to be really sensitive to sources of this, such as TV and radio transmitters, which create a specific radio frequency as part of their transmission process. Two other common culprits are two-way radios and cellular phones. Your only way around this is to use shielded network cables like shielded twisted pair, STP, and coaxial cable. Rare today are RUN, EMI, RFI, immune, but pricey fiber optic cable throughout your entire network. Split pairs. A split pair in a wiring error where two connections that are supposed to be connected using the two wires of a twisted pair are instead connected using two wires from different pairs. Such wiring causes errors in a high rate data lines. If you buy your cables pre-cut, you won't have this problem. So I'm going to leave it here to say this video. If you like listening, please consider like, sharing and subscribing. Thank you.